straight into it. The first thing we're going to talk about is biocentrism. Biocentrism is an idea that has been put forth into the mainstream at the moment by a guy called Dr. Robert Lanza, and he is a brain surgeon. He's a super smart dude, and he's decided to start writing about quantum physics. And this is something he hasn't really been trained in at all. He's actually really like a hardcore geneticist and stuff like this. But he's one of those people who's so smart, and he's kind of gone, oh, you know what? I really need to share some of these ideas I'm having about this. And the basis of all biocentrism essentially is that consciousness is the beginning of everything we're aware of in our physical reality. That the planet wasn't here like kind of a smouldering rock and eventually life came to the planet. It seems to be there's something else going on where our entire universe and our entire, especially our solar system in particular, has been finely tuned for us to be here. Extremely finely tuned. I mean, if the Big Bang happened like just like a sliver faster than it did, everything would have expanded so fast that atoms wouldn't have had a chance to get pressed together and create complex atoms like carbon. Everything would have been like plain vanilla hydrogen, and we need carbon to exist, for example. So there's all of these variables in gravity and in cells and in atoms that actually make us hold together. So it's really, really incredible once you go into these variables, and there's hundreds of them that allow us to exist. And it kind of boggles the mind that everything is so perfect. Not just the Goldilocks zone where our planet is to be the right temperature for us to be here, or the fact that the atmosphere holds onto the planet, so we've got atmosphere. It goes so far beyond that. So it gets into a whole mind trip of what's actually going on, this kind of grand design that allows us to be here. So biocentrism, essentially, we can approach it like this. We start to look at consciousness being the source of events. So you get that age-old thing, if a tree falls over in the forest and there's no one around to hear it, does it make a sound? Well, you need to look at what a sound is. So a sound has two components, a source and a something picking it up. We're picking it up. So when the tree falls over, in the air, you get these pulses of sudden pulses of particles moving along, right? And when they hit our ears, those pulses, we translate those pulses into a sound in our head, right? So half of the component essentially of that sound is us. If we weren't there, there would just be pulses of air moving around, pulses of particles. So the entire concept of a sound is something that you would be imagining happening in the forest if you were there listening. But if you weren't there, there'd just be pulses of air. Okay? So in just that way, we can see that consciousness is one component. Us picking up that sound is one component of the sound actually happening. So if the tree fell over, there would just be pulses of air. And a pulse of air without ears is essentially not a sound. It's just that. So what we perceive as reality is a process that has to involve consciousness. And we'll get into this more and more. It gets more and more screwy, guys, so it's just a different way of looking at things. So this idea of biocentrism is that all particles, and we're made of particles, we're talking about, essentially in atoms. We're talking about nucleuses of atoms, and we're talking about electrons. Now these experiments that we're going to talk about soon, they've also done all these experiments with larger groups of atoms. The one they use the most is called a buckyball, named after Buckminster Fuller, which is a ball of carbon atoms, right? And they can get these same effects where they realize that these balls of atoms, when it's not being observed, it turns into a wave of energy. And not just a wave of particles, we're talking about just this group, or one electron, let's say. The electron is a solid thing. When it's not being observed, it turns into a wave of possibilities, a wave of energy. And this is really quite strange in the sense that when we observe an electron, it stops. If we want to measure a particle, measure an electron, measure an atom, then it stops and we can observe it. So the process of observing, this can be taking a photo, all right, because eventually we'll see the photo. Basically interacting with it in any way is make it going to stop and be in a determined state. All right, so before we're looking at anything, everything exists, in an indeterminate state. And this is when things get really strange, in the sense that we can look at everything that's not being viewed as a wave of possibilities. Waves of possibilities. So, in the bathroom through there, none of us are in there. So at the moment, this whole idea is that everything happening in that bathroom is happening in a wave of possibilities. And when you open the door, in physics they call this a wave function collapse. So there's a lot of this terminology is a bit awkward. Wave function collapse. Wave function collapse means that the observer has looked at a wave of possibilities and it's made it just stop. Okay? So you are a part of what is happening in that bathroom when you look at it. And then you leave again, it goes back into an indeterminate state. There's this whole idea that was promoted by Einstein called locality. Locality means that that bathroom is exactly how it is now, even though none of us are looking at it. Right? It's existing without conscious interpretation. This has been proven wrong for 75 years. 75 years. So all the experiments we're going to look at mostly, especially the double slit experiment here, has been repeated over again for 75 years, like a lot. So we can actually see through the scientific method that this seems to be what's going on. In this way, it's important to realize though, that anyone who thinks they understand quantum physics doesn't understand quantum physics. The results of quantum physics point out that we don't actually understand what's going on. However, with some of these experiments, we can actually start to get a bit more of a clear picture on some of the healing anomalies that people can go through and start to more deeply understand how these take place. So, we're going to talk about constructive and deconstructive interference. The best way to see this is on like a reasonably calm day, if you go down somewhere like Broken Head or something like that, and you see waves interacting with each other. Sometimes on the beach you'll see like a wave, especially if you go down to town, and there's waves coming in towards the beach hotel, and they hit the rock wall, and then they go back out. And then you'll see that wave going back out, and it'll hit another wave, and it'll shoot up. And it will shoot up double the height. So if two peaks hit each other, the amplitude goes right up. If two troughs hit each other, they'll go right down. Okay? Now, if a peak hits a trough, it goes neutral. Deconstructive and constructive interference. So, if you look at a wave, like that, so if this is where the wave begins, and you add it to another wave like this, they're in the same place. It's just going to go peak, trough. Like this, it's going to get doubled in size. This is constructive interference. Okay? Does that make sense? Two waves together, right? Now, if these waves are moved out of phase, okay, that means that we're going to have a peak hitting a trough. And the waves are the same size. That means if we put those waves together, they're going to delete each other. But being fully aware that as you watch in the ocean, these waves keep moving. So if you have two sources of waves, and you can see this sometimes in harbours and stuff like that, and you can do this with light. All waves do this, right? All waves of energy does this. Where you have two sources, right? And they start to interact with each other. And each time one of these crosses like this, that's a spot of constructive interference. And each time you have two troughs in there, you have deconstructive interference, just like over here. Now a really good way to experience this is to, does anyone know where you see this sort of thing all the time?
In the rain.
Eh?
In the rain. Rain in water.
That's right, yeah, you can do that. Yeah, we can do it in a cup or in a bowl. But one of the most common places we actually see this is at a festival. And if this is the stage here, and this is the two main speakers, and you're out here in the crowd, and you walk on this angle, you'll notice sometimes that the highs in the music get higher and the lows get lower. It's easiest to tell with the lows. So especially with the bass, you'll find you'll be here with your mate, and you'll be talking, and then you'll go over here, and the bass will go, woo. You just walked into a spot where that frequency is having a deconstructive interference. And you go like, whoa, that's too quiet, I really want to hear the bass. And you go over here and you're like, yeah, sweet, okay, cool. Or it'll be too loud. So I think there's a classic case in the 70s when they started making huge sound systems, where they got everything like that. And in straight lines out into the festival of these constructive interferences of the low frequency, everyone's eardrums got blown. But then the person 5 meters over here, they were fine, because they were sitting in a deconstructive zone of interference. Alright, this is kind of in the Led Zeppelin days and stuff like that when stuff was louder.